Alright, notes number 10, factoring trinomials using the box method. 8 steps here. First step, it says to make a 4-square box. So the first thing we have to do is make a 4-square box. So we have a 4-square box. And step 2 says put the x squared term, so here's your x squared, goes in the first box, top left. And then you put the constant term, which is this one, in the bottom right. So we have 16. So that's step 2. We put the x squared and we put the constant term down there. Step 3 says to multiply the constant term by the lead coefficient. Now our lead coefficient here is 1. So we want to do 1 times 16. So 1 times 16 will give us 16. So that's step 3. Now step 4, we want to find the factors of this 16. Well, factors of 16 are 1 and 16, 2 and 8, 4, and 4. Now, step 5, we want to add these factors to figure out which will give us this negative 8. So if we add them, this is 17, this is 10, and this gives us positive 8. But we want negative 8. So in order to make that negative 8, we can do negative 4 times negative 4, which will give us the negative 8. And now step 6, we put one of the factors. So these are my two factors. So I'm going to put one of them here and put the other one over here. So I put negative 4 here, and I put negative 4 here. So now I put my two factors in there. And then we look to see, we'll look for the factors here. So we want to factor our top row. We want to factor the top row, the bottom row, the first column, and the second column. Well, my top row, the only thing that these guys have in common is going to be, they're going to have an x in common. And then the bottom row, what do these two numbers have in common? A negative 4. What do these two numbers have in common? X. And then we factor this. What do these two have in common? Negative 4. So that means that my two binomials, change the color here, we have one, which is x minus 4, and the other, which is x minus 4. So we have x minus 4 times x minus 4. Alright, so that's how we get these answers. Alright, we're going to do 3 more examples, so hopefully by the 4th example, it'll make some sense. So, once again, we're just going to repeat these steps. So we're going to draw our 4x4 box. So step 1 is I drew my box. Step 2, I put this first term and this last term. So I start to fill in the box. So I fill it in with x squared and at negative 24. We want to multiply the lead coefficient, which is 1, by the constant. So 1 times negative 24 is negative 24. So the next thing we want to do is we want to start to factor this. Well, I'm going to write my factors down. I have 1 and negative 24, negative 1 and positive 24. I have 2, negative 12, negative 2, positive 12. 3 and negative 8, negative 3, positive 8. 4 and negative 6, negative 4 and positive 6. So now I have all of the factors down. But we need to figure out which of these factors will add to give us that negative 10. Well, which of these factors here will add to give us negative 10? Not this one. 2 plus negative 12 will give us negative 10. Negative 2 plus 12 is positive 10. So the two factors we have are 2, this 2 right here. Change that. So we have this 2 right here, which we're going to write in here. So I'm going to write it as 2x. Then I have this negative 12. I'm going to write in my other box. So I'm going to write it as negative 12x. Now the next step, it says we want to look at for the greatest common factors. So we just want to look for the greatest common factor. Make this a little bit easier. So if I take a picture of this, put it. So I want to look at the common factor between these two numbers. Well, what does x squared and negative 12x have in common? They both they both have an x. So I'm going to pull out an x. That's what they both have in common. Now we look at what do 2x and negative 24 have in common? They both have what number in common? They both have a 2 in common. So we're going to place a 2 here. Now we look at these here. What does 1x squared and 2x have in common? They have an x in common. And then what does negative 12x and 24 have in common? Negative 12. Which means the factors, we have this factor right here, which is x minus 12. We have this factor right here, which is x2. So we're going to say that's x plus 2.
Let's go to problem 3. Okay, so first we make a box. Then we put the x squared, the 3x squared, into the first box. And you put the constant term in the lower right. Then we multiply the constant terms. 3 times 4. So we're just multiplying the numbers. 3 times 4, 12. Now we have to find the factors of 12. So it's 1 and 12, 2 and 6, 3 and 4. Which of these add up to be 13? Oh, so it's going to be 1 and 12. So we put 1 here, 12 up here. We have to put the letter x up here. So what does these two have in common? It's going to be, we put it up here, x. And what do these have in common? 4. So now we do, what do 3 and 12 have in common? 3. But they also have an x in common, so we put 3x. And then what do these have in common? 1. So put a 1 here. Since they don't have anything in common, just so that's the answer.
So let's look at the last problem. Okay, so step 1, make a 4 square box. Step 2, put the x squared, so it's 2x squared. And the constant term is negative 15. Step 3, multiply the constant terms by the speed. coefficient 2x squared, no 2 and times factor negative 30. No. 2 and negative 15. 3 and negative 10. And 5 and negative 6. Now, which of these ones gives us 3 and 10? 3 and negative 10. Step 6 says put one of the factors in the upper right hand box and the other factor in the lower left hand box. So negative 10 here and 3 here. Step 7, factor the top row, bottom row, first column, and second column. We need to put x's in the 3 and 10. What do 2x squared and negative 10x have in common? They have 2x in common. It's not working. These have 3. What do these have in common? They have 3 in common. What do these have in common? They have the negative 5. These have an x in common. So write these ones as one factor x minus 5, and these ones in other factor. So it's 2x plus 3. And now that's your answer.
That's notes number 10, factoring using the box method. Thank you, Tatiana and Mirna.